everyone. So this first video that I'm going to be sharing with you is all about variables, units, and operators. The essential question is, what are variables, units, and operators, and how do I identify and use them? So a variable is just something that you can scientifically measure in a numerical value, and that can change over time. So when we talk about numerical value, we're talking about an actual number. So it's something you can measure with numbers instead of saying something like that thing was hot, cold, or very hot. You need to have numbers. So a couple of examples of non-variables, things that are not variables. A dozen, that's a very specific number. And it's just something that you're counting. There's no way to measure it by really it's all you're doing is just counting something. Your brother, how would you measure the value of your brother exactly in a number, with a number? There's no way to do that. Another one, how good a pizza is. That's something that's really an opinion. There's no way to scientifically measure that with numbers to talk about how good a pizza could be. Now, these next few are variables. Your height, that's something that you can measure using a measuring tape or a meter stick. Or a ruler if you're very short. And that's something that is a numerical value. I am 5'1", and so that's something you could actually measure with numbers. And that is something that can change over time. The speed of a car, that's definitely something that can change over time. And that's something that can be measured using a lot of different tools by figuring out how far an object goes in a certain amount of time. And this last one is just the money in your wallet. That's something that can definitely change over time. You can measure it by like using different currencies. So in the US, it's $1. In another country, it might be something else, but that's also a variable. Now, why do we care about these variables? Well, there's this key idea. There are these 6 fundamental variables, and we'll only in this course focus on a few of them. But these 6 fundamental variables describe properties of all objects in our universe. These are the main ones that we can use to describe a lot of different situations in our universe. So time is one of them. Distance is another. Mass and energy, and we kind of put those together because I go over them in one specific unit, and you can see a lot of similar connections between the two. Now, those 3 are the main ones that we're going to talk about in this first course in physics. Now, charge is something that comes up later on in the second semester of physics, and that's basically something that could be positively or negatively charged. Color is another one, also talked about in second semester. And spin is the last fundamental variable, but this is one that we don't really talk much about in the first year physics class, but it is something that definitely comes up in other physics classes and other classes like chemistry as well. Now, here's the reason why these are important. Every other variable you could imagine, something like force, something like pressure, something like velocity or acceleration, those are also variables. But if you notice, they're not on this list. So all other variables used in this class or others can be created by combining these 6 in different ways. And so I'll be showing you a few examples of that this semester. And really what's the bigger picture in this all is that by doing that, by mixing these variables up in different ways, we actually can create and invent equations. That's how equations were created. Now, oops, I always forget that I have these pictures here. Sorry. But next thing we'll go on and talk about our units, because those are directly connected to variables. So a unit can be described like this. When a number's unit is given, it gives meaning and size to that object in the physical world. And so that sounds a little cryptic and mysterious. So I'll give you some examples in just a sec. So one of the big things with units is that it actually helps us identify what variable, what variable it may be if you don't know. And so you can work backwards in there too. Now, here's why this is important. If I tell you I'm going to give you 6, that could mean a lot of different things. It could mean I'm going to give you 6 pieces of candy or 6 bags of poop. And so the unit is what gives that number 6 meaning. So this next slide is something that I think would be very important for you to kind of look over and try and understand. Not something you have to memorize, but this slide gives you a good example of what variables are, what their symbols could be, and also what units you would normally see those variables in. So time is one of those fundamental variables. The symbol for it is a lowercase t. And that's what you would use if you're trying to write something in shorthand or if you were trying to put something in an equation. The units to describe time, I haven't put all of them on here because that would take a lot of space, but I put some of the main ones. Time could be measured in seconds. It could be measured in hours or minutes. Mass, or you can think about how much stuff is in an object, or a lot of times we think about how heavy something feels. The symbol for that variable is a lowercase m. Some common units are kilograms and pounds, and you might notice some of those units are in yellow, and I'll explain that in just a sec. The last one is energy that I give you an example for. That's actually a capital E because a lowercase e actually means something else in physics. And so here are some common units: joules, calories, and calories are exactly what you're thinking. It's if you think about when we eat food and it has calories, well, that's actually energy that you're eating. And so we eat, of course, because it tastes good a lot of the times. Food is delicious, but we really are eating to give ourselves energy so that we can do everyday activities and survive as humans. And so I'll actually go into more about energy later on in this semester. Now, I mentioned those yellow words up there, the units like seconds, kilograms, and joules. These are actually called SI units. They're basically the scientific units that all scientists across the world have generally agreed to all use so that we don't have to convert between one type of unit and another. And I'll be showing you guys some examples of how to do that too. And so this page, I think, is one that if you have a good understanding of how to describe what variables in general are, and be able to describe what units are, I think you're going to be doing pretty okay. And so this next piece is kind of the last big topic in this lecture, and it has to do with what I call mathematical operators. Some of these you are very used to seeing, but they're basically the symbols and shortcuts that tell you what math operation to do. Are we wanting to add, subtract, multiply, divide, what? And so you have seen some of these. If you want to add two variables together, you use a plus sign. You might have to take the square root of something, which I'm going to tell you right now, you don't have to do in this class, so you're okay. We don't normally use this symbol in this class much, but we talk about this when we say, hey, let's compare these two values. And so that's a comparison. Now, here's what I want to show you. The actual two operators that might be new to you. So delta is one of them, and that's basically a triangle. That is, if you ever see that in front of a variable, like delta t for delta time, here's what that actually means. Here's what the delta means. It means that the amount, like you're trying to figure out how much that variable has actually changed from the start to the end. So if I started my time at 0 seconds and then I took my time all the way to 10 seconds, if I wanted to find the delta t, or you can say change in time, what that means is I'm trying to find out how much time has passed during there. You're trying to figure out from the initial time, which was 0 seconds, to the final time, which was, what did I say, 10 seconds? And so how much time has passed there? 10 seconds. Now, here's an actual example I'll show you here. So let's say a dog starts running at 12 and stops at 12:45. Your initial time is 12. Your final time is 12:45. And so if I'm trying to find the change in time or the delta t, if you're trying to find the change in something, you're subtracting from your final, from your initial. And so we'll do some examples with this next week. So the delta t, the change in time, 45 minutes. Now, let's say the variables actually never change. And I'll give you a different example instead of time. I'll say distance. Let's say I am 10 miles away from home. And then I just sit there. And then I sit there. And then I'm still 10 miles away from home. Well, that never changed. And so if I were to ask you, hey, what's the change in distance? Like of what I did? Well, I never moved. So that's 0. So that's all that means. Now let's go to this last one. So sigma is the other operator I wanted to show you all. The nice thing is it's the opposite of delta. And so if you know one of these, you know the other. Sigma is this funny looking E, okay? And what this means is you're trying to find the total or the sum. And so instead of subtracting like you would do the last one, you're actually adding for this one. So it says here, if you see a sigma symbol before a variable, like sigma t or something, like that would basically mean the total of that variable. So let me give you an example real fast. 4 friends, each have $10. If I wanted to find out the sigma money or total money, you just add them all together. If 4 friends have it, there's 10, 20, 30, 40. So that's the total. And that's all this is. So you will end up seeing a little bit of the delta, that triangle sign or symbol, and then the sigma, this funky looking E. And my hope is that you guys will be able to understand the difference between the two and be able to calculate those things. And so that's basically it. Here's your essential question again. What are variables, units, and operators, and how do I identify and use them? So see if you can kind of get yourself to answer that as a way to help you see if you understand this material. All right, thanks a lot.